This video demonstrates an interactive visualization tool designed to help urban researchers investigate how suburban residents in the Tallinn metropolitan area use space in the city. The urban researchers wanted to learn about the spatial and temporal connections of suburban Tallinn to the city and the land use conception by suburban residents in the city. We were supplied with mobile phone-derived locational data at fixed temporal sampling intervals from 277 of suburban residents, together with their socio-economic data and a land use classification scheme of the Tallinn city. We used a user-centered approach by firstly setting up meetings to collect a list of questions from the urban researchers. We further categorized the questions into 3 user tasks, including identification, localization, and comparison. We used these questions and tasks to inform the design of 5 coordinated views. The first view represents individuals' movement sequences traveled through land uses over 8 days. Each row represents one individual's movement. Each wider column indicates 1 day. Land use visits are represented as rectangles whose color indicates land use type, position indicates arrival and departure time, width indicates stay durations. The second view represents socio-economic characteristics of suburban residents. Its row corresponds to the appropriate rows of the sequence view. We applied pattern of symbols to represent gender, employment status, age, income, and education. Thirdly, we designed a dynamic legend view by using the width of a legend bar to represent the total stay durations of 8 days of the selected urban residents. The fourth view is a connection to the city view to highlight when suburban residents enter or leave the city. Suburban residents are arranged from left to right in the same top to bottom order as in the sequence view. The y-axis represents 24 hours of 1 day. Times in which a resident is in the city are shown as gray columns, whose bottom and top represent the entry and exit times. Suburban residents who stayed in the city all day long are shown in a lighter gray. Accumulated counts for each suburban resident of entry and exit events are shown above and below the line in dark green in the B area. Similarly, the accumulated entry and exit events per hour are shown in the C area. We put the Tallinn land use map in the remaining space to indicate the positions of selected residents. We have designed multiple sorting functions in which items are sorted by different aspects in turn. I now demonstrate the tool using some user questions. For example, for question about how many persons have regular connection to the city, we firstly sort suburban residents in ascending order of the number of times they were entering the city on the first day. We then sort them by land use types visited by residents at working time, for example 11 a.m., leisure time, for example 8 p.m., and home time, for example 2 a.m. The result of this 4-level multiple sorting is several visually identified clusters of colored rectangles, like the group B and C in the sequence view. It indicates that these residents regularly visited the same land use during weekdays. Therefore, they have temporal periodicity of the connection to the city. The bar chart at the bottom of connection will help us identify how often these connections are made. Most suburban residents have multiple connections to the city per day. The bar chart to the right shows that the majority of suburban residents enter the city between 7 to 9 a.m. and left between 7 to 9 p.m. Switching types can compare for different days, like at the weekend, suburban residents enter the city later and over a longer time than during weekdays. By moving the months over suburban residents, the dynamic legend indicates that each participant only visited limited numbers of land use categories. The land use types visited are consistent. We further identify relations between the patterns and the socio-economical characteristics of suburban residents. We further sort them by employment type. Pupils, workers, and businessmen have more irregular weekday patterns, while the land use consumption is more homogeneous for home workers unemployed and retired during the whole week. Taking only group worker, we further compare the difference between males and females by sorting them by gender. Female workers spend more time in mixed building area, shown as pink in the sequence wheel during working hours. They have fewer connections to the city than their male counterparts. We provided the tool to the urban researchers. They explored data as the way they like and reported advantages in using this visual approach for carrying out their tasks. They agreed that the developed tool are useful and has high relevance, helping them discover connection between different spatial units, finding spatial temporal patterns related to subgroups, and learning about urban structures. They considered that these approaches would be applied directly to other aspects of urban research and planning applications. They also suggested that further combining these individual-based visualization methods with more traditional analysis methods